All right, so whenever we're making solutions, something gets dissolved in something else, and sometimes something does dissolve, sometimes something doesn't dissolve. So for example, if you tossed some salt in a cup of water, that salt would dissolve. If you threw a rock into that water, that rock would not dissolve, right? So what makes something dissolve versus not dissolve? And our general rule of thumb here is that like dissolves like. So similar things will dissolve each other. And so what we're talking about similar here is the intermolecular forces, right? So what we learned about last chapter. So we'll have our cup of water here. And then we're going to have some kind of component here that we're going to try to dissolve away. And as we know, there's intermolecular forces keeping these things together. And so when we drop them, the question is, can we break those intermolecular forces and form new intermolecular forces? And so the question and the answer to that depends on the properties of the solute and the solvent. If they are very similar to one another, they will dissolve, hence like dissolves like. So for example, in order for this to dissolve, we have to break the solute intermolecular forces, right? We have to break the forces that are keeping these two little particles of solute together. And the way that we can break them is that we can form new intermolecular forces. So we can form solute, solvent intermolecular forces. And if those intermolecular forces are similar, they'll be strong enough to break them. So for example, when we dissolve this in here, we'll have individual particles, and then the water would surround them and form new solute solvent intermolecular forces. And again, it's like dissolves like. So if your two components are similar to one another, they're going to dissolve. If the two components are very different from one another, they will not dissolve. So let's take a look at two very different solvents and think about which compounds are going to dissolve in which component. So the two solvents that we're going to take a look at is water, which is H2O. Remember, water is very polar as well as having hydrogen bonding. So it's going to be able to dissolve things that are very polar. And then our other solution is hexanes, which is CH3, and then 4 of these CH2 units, and then 1 more CH3 at the end. If we think about carbon-carbon bonds, those are very nonpolar. We also said carbon-hydrogen bonds are nonpolar. So overall, hexane will be a very nonpolar molecule. And so depending on what we try to dissolve in these two solutions, some will dissolve in only one of them, some will dissolve in both, but most of them are going to have a preference for one or the other. So if we take a look at something like sodium chloride is a salt, which means that it's an ionic compound, right? It's going to have a positive and negative charge. And so we can think of that being as very polar. And we think about which component it's going to dissolve in. Well, very polar, that's more like the polar water. And remember, water can form ion dipole intermolecular forces with ions. And so it'll be very soluble in water and not soluble in hexanes. Another analogy of hexanes would be like oil. So again, if you try to take some salt and you dissolve in water, very easy. Try to dissolve that salt in some oil, it's not going to dissolve. Next component will be methanol, which has the formula CH3OH. And then remember, whenever we're given chemical formula, there's usually clues within the chemical formula. So we have this OH here, that's telling us that we have an oxygen-hydrogen bond, which is a polar bond and is capable of hydrogen bonding. Remember, OH bonds are one of our types of hydrogen bonding. And so if we think about which solvent that's going to be soluble in, that's also going to only be soluble in the water because the water, again, is polar and capable of hydrogen bonding. Then finally, we think about carbon dioxide. For carbon dioxide, we have to actually think about the structure of the compound. So as we previously discussed, hydrogen or carbon dioxide has polar bonds. However, they cancel one another out and it becomes a non-polar molecule. And so if we think about which one it's going to dissolve in, it's going to prefer to dissolve in the non-polar hexanes. That doesn't mean that you can't get any in the water, just not as much as you could into the hexanes.